Alright. I think I'm recording now. I never quite know for sure. Alright, so let's take a look at this problem and write the polynomial function. It's not passing through the origin. It's going up to the right, so I need a positive leading coefficient. And I don't know yet what that's going to be, but I can use the y-intercept to help me determine it. So for my polynomial function, I'm just going to call it p of x. It has an x-intercept at -3 in factored form. That's x plus 3. It has an x-intercept at +1 in factored form. That's x minus 1 and x minus 2. But this is not my answer. I don't know what that leading coefficient is going to be. I do know that this y-intercept, that it's passing through the point 0, 3/2. Okay, so when x is 0, then I know that this product, I know this product should equal 3/2. So I've got one equation, one unknown. I can solve for that. We've got 3/2 is equal to positive 3 times -1 times -2. It's going to be a positive 6. So if I divide both sides by 6, or if I multiply by 1/6 here, I'll multiply by 1/6 here. And this 6 and this 6 cancel. So I have a equals, and 3 goes into 3 once, 3 goes into 6 twice, 2 times 2 is 4, so I have the a is 1/4. So my final answer is that, I hope I got this in class, x plus 3, x minus 1, x minus 2. Final answer. Alright, let's look at the next problem. Same idea. I've got p of x. I know that since this is going down to the right, that I should make my leading coefficient negative, and I probably didn't ignore that in class. Sorry if I did. Let's look at -3. Since it's doing a touch and turn, my multiplicity is an even number, so I'm going to pick 2. Here it's a cross at 1, so I'm going to, in factored form, it's x minus 1. My coordinates of my y-intercept are 0, 4.5. So I know that when x is 0, that I should get 4.5. Let's solve this for a. I've got 4.5 is equal to 3 squared is 9, but times a -1 is a -9. And divide by -9. Let's go to the calculator and get it. 4.5 divided by a -9. And I'm getting -1/2. 0.5 is the same as 1/2. So my final answer here is -1/2 times x plus 3 quantity squared times x minus 1. So here for this one, again, this y-intercept has coordinates of 0, 1. I'll call it p of x since it's a polynomial function. I'll use the y-intercept to help me determine what a is. It has a 0, an x-intercept at -1, but in factored form that's x plus 1. Since it's doing a touch and turn, I need this multiplicity to be an even number. And the same here at +1, I'll write it in factored form as -1, and since it's doing a touch and turn, that's squared. So every point on this graph satisfies this equation, and I'm interested in using this point on the y-intercept when x is 0. And I'm really picking it because 0 is easy to do arithmetic on. I should get 1. So on the right hand side here, negative 1 squared is 1. 1 times 1 is 1. I just have 1 times a equals 1. Well, hey, a has to equal 1. So shrink this up and let's write our final answer. It so happens that now I'm glad that that's positive because it's going up to the right, and I knew that the leading coefficient would be positive. So I've got p of x is equal to just x plus 1 quantity squared times x minus 1 squared. You can put the 1 there if you want, but it's implied. So here's my final answer for this one, for part C there in problem 1. Alright, so let's take a look at these and answer these all at the same time. How do I know whether or not this is a polynomial function? I look at the exponents on the variable and I make sure that they are positive exponents, positive integer exponents, 1, 3, 2, 4. I don't see any negative numbers. I don't see any fractions. I don't see any square root of x or any radical x. I do not see any variables in any x's in a denominator. It is true that this is a polynomial function. And so since it's a polynomial function, I can determine the degree and the leading coefficient. When I look to the degree, even though this is written by term, it's not in standard form. If I look here and scan for the biggest exponent, it's 4, so the degree is 4. And the leading coefficient is this 2, because it's the number that's in front of that term with the largest degree. For the end behavior, I want to use the information I just figured out, that the degree was 4 and the leading coefficient was 2, which is positive. So I know when the end behavior is going up, or excuse me, when the end behavior is together, it's even. So A and B would both be situations where the degree is even. And that's what we have in this problem, is that 4 is even. Over here, both of these pictures, since the arrows, the tails are going in opposite directions, would be odd degree. Alright, now in each one of these pictures, if I look to the right, the leading coefficient will be positive if it's going up. So the leading coefficient is positive, is what we have here with positive 2. Over here, had that 2 been a negative, had this leading coefficient be negative, I would have selected A. But excuse me, I would have selected B. But A is my final answer. Over here, it's going up to the right, so the leading coefficient would be positive. It's going down to the right, the leading coefficient would be negative. So for number 5, it's A. What's the y-intercept? Well, you let x equal 0. So it's just this constant term. So this y-intercept is y equals, well, 6, because all of these x's are 0. So it's 6. What are the x-intercepts of this? Well, they have factored part of it for me, so let's continue and factor the rest of it. Let's set it equal to 0. X squared minus 1 factors to x plus 1 times x minus 1, and 2x squared minus x minus 6. Go ahead and do your x method, and you should get, let's see, if I'm trying to get a negative 6, they'll have a positive 2 and a negative 3 multiplied together give me negative 6. Negative 6x, which, that is not. Let's switch places with this. I want here a negative 4 and a positive 3. Sorry about that. 2x squared minus 4x plus 3x is a minus 1x, and 3 times negative 2. So there it is. Like I say, come over and do your x method if you need to. Don't make a silly mistake like I almost did with trying to do it in your head. The x-intercepts are negative 1, positive 1. And here, if you set that equal to 0, you would subtract 3 from each side and then divide by 2. And that's x equals 2. So it has 4 x-intercepts, and there they are. All right, now it wants me to, is this the same problem? Okay, the same problem, the same x-intercepts, x squared minus 1, 2x squared minus x minus 6. So it's the same problem. So when I factor it, I'm going to get the same zeros, this negative 1 and positive 1. And I'm going to get negative 3 halves and positive 2. the multiplicity on each of these, if you come back in factored form and look at the exponent up here, it so happens for this problem they're all 1. So the multiplicity for each 4 of these zeros for each of these is 1. And this is wanting me to describe how the graph will intersect the x-axis. Will it come over to the x-axis and say at x equals 1? Will it cross, or will it come over and do a touch and turn? And it might do that from above or below. Since all of the degrees here are odd, we're not going to have any touch and turns at these 4 zeros, these 4 x-intercepts. They're all crossing. So to make my table easier to read, let's just draw lines in here. Try to. There we go. There's our answer for 8. Let's write this in standard form, so let's multiply it together. So let's make a table. X squared minus 1, 2x squared minus x minus 6. So if we multiply these guys, we get 2x to the 4th, negative x to the 3rd, negative 6x squared. Then over here, negative 2x squared, positive x, and negative times negative is positive. So I've got 2x to the 4th. I've got minus x cubed. With this, negative 6x squared and negative 2x squared is a negative 8x squared plus x plus 6. That's my final answer because that's in standard form. If we go back and look at this problem, 2x to the 4th, I think we've been working with the same polynomial. 2x to the 4th minus x cubed minus 8x squared plus x plus 6. So I had you working with the same, for the majority of these problems, they were the same problem going through it. So hey, I hope that helps, and I'll talk to you later.